thank you, panelists, for taking this time. We really appreciate you giving back like this. My name is Blake Hament. I'm a RAS SAC Co-Chair. So that just means I'm a student, a member of RAS, and the Student Activities Committee. We put on activities usually for IEEE conferences like ICRA, IROS. Recently, that's been a little bit tough because we're virtual, but we're experimenting with things like debate, trivia, video competitions. So please keep an eye out for that, students, at your next conference. So we're going to go through some submitted questions, and then at the end, we'll have a chance to go over any new questions. So throughout the discussion, if there's new questions that come up, you can send a message to Kara, and she'll keep track of any new questions, and we'll hit those at the end. For our first question, I wanted to start with kind of an icebreaker and take our panelists back to when they were students. So I want you to think back, what did you love about being a student, or what did you hate about being a student?
I can get started if you like.
Please, thank you.
Go for it.
To break the ice. What did I like? Actually, to be honest, a lot. Let me talk about some of the learnings that I experienced as a student that I, from today's perspective, also consider most valuable. And to me, still the biggest one is that I learned to lose respect. Like, I remember when I was a young PhD student, I was looking up to the big names in the research community, written big papers, big books. And when you, at some point, as a PhD student, get to travel to conferences and you get to talk to them in person, you also see that they are humans like you and I. And if you look into their work, I'm totally not disrespecting the work, so not discrediting the work at all. But you get to see that these are human beings, and you're one of them. So that gave me kind of a very different perspective in the world. And then that being said, one part that I feel I was very fortunate, my supervisor sent me to conferences fairly early on. That's definitely was a piece that I enjoyed, and as some of you looking also at Kara, at Amy and Alexis who are here too. I'm doing that even today, like traveling to conferences and having a network there, and it's part of the family to a large extent that started to grow in my case like 20 years or almost 20 years ago, and that's certainly the positive aspect. To share some of the things I did not enjoy as much. When I started, I thought I found a mathematical problem in real-time motion planning, and I thought I can solve it in like a year or two, and then I just write my stuff together, and then I'm done. And in my case, it took me actually 8 years, and so I was very miscalibrated on the complexity of what I was trying to tackle. There was a lot of uncertainty. Even after 6 years, I wasn't sure whether that's going to work. And I was really afraid, is this going to be like an endless rabbit hole that I will never get out of? And I will still remember the day when actually the moment even, not the day, when I found the last puzzle, the last puzzle piece. And that's very rewarding at the end, but it was struggling for many years to see whether this is actually going to work.
Very insightful, thank you.
You can go next. Sure. So what did I enjoy about being a student? There is something about the open field, because that's usually when you start the research and there are no constraints. And any direction is good direction, it's open, and that can be overwhelming, but there is something about being able to having the time to read a lot, to ask yourself what are interesting problems, to tackle where your interests are, why are you interested in certain things, and then pursue these. When you're starting PhD or you're starting the research, that's all you're doing, right? It's a pool. Your focus is fully on that one aspect, and that's perhaps the only time in your career that that happens, and that's really precious. The downside is, Torsten had mentioned, uncertainty around whether whatever this thing is going to work, when it's going to work, and so on. And that intuition and so on takes years to develop, to kind of get the taste and feel for whether it makes. And I'm going to quote one of my professors that said that the only research feels like banging your head on the wall, and after enough experience, you kind of know it's going to crack at some point or not. You just need to get to that point, but it still feels that navigating that uncertainty and managing it, right?
Mm.
And then the second thing I really enjoyed about the PhD is really discovering the community, the robotics community, going to conferences and kind of becoming part of a larger global community, which was very new to me, and it's really amazing to see that.
Awesome, thank you.
That's a lot of things that I want to, just build on, what Torsten and Sandra said, because a lot of that just resonated with me. So for example, when Torsten was saying how it was important during the PhD when he learned to lose respect in a good sense, right? And I also very distinctly remember the time about 3 years into my PhD when I lost my fear to ask questions at seminars, right? Because before I was so afraid, what if, I'm asking a question and I'm just revealing my ignorance? It's like the answer is so clear and I just didn't understand it. And then about 3 or 4 years in, I started realizing that if I've paid attention, reasonable attention during the presentation, and I don't understand something, it's not on me. It's probably the presenter didn't explain it clearly enough or at a level accessible to most of the audience, which they'd like to do. So I stopped being afraid to ask questions. And that for me was kind of like, I felt that I had leveled up in a way, very similar to what Torsten was saying, kind of losing respect in a good way. And, what Sandra was talking about and also Torsten about going to conferences and networking, traveling is a terrific experience. Blake, maybe you can mute because I think I'm getting some echo from your computer. Okay. So the one thing that I would make sure to suggest to all PhD students who are traveling and going to conferences and thinking, I need to network. And the reflex is to say, I need to network with the big names in the field. I want to find the dinosaurs and somehow get myself into the conversation and get them to notice me. And, and that's hard, and it can be stressful. And, sure, it's not a bad idea to do that. Just, don't overdo it. It's not a bad idea to do it, but just make sure you also network with your peers, right? With the other lowly PhD students, the other, second year or third year or fourth year PhD students from other universities. Just network with them at conferences as well, for 2 reasons. First is you want to have, a circle of people that at these conferences, that you see again and again, conference after conference, that you hang out with, that you go get a sandwich during the break or a drink in the evening after the sessions. It's so important just for your enjoyment of the conference. And then the PhD students of today are going to be the dinosaurs of tomorrow. So you want to network with your peers now because, 15 years from now, you along with them will be, the next generation of people making a difference. So it's a good idea to network, to make friends and connect with them now. And it'll make conferences just so incredibly enjoyable. I'm also very lucky that I remember my time in the PhD so fondly. It was some of the best times of my life. Maybe there is kind of a selection bias here. All professors fondly remember their PhDs because people who really, really hate their PhDs don't stay on as professors. I don't know. Maybe there's a selection bias. But I just, both professionally and personally, and, it's a long time. I was lucky. I had a terrific relation with my advisor, and that's just the nature of the beast. You know, it's so important that at a human level you get along well with your advisor, and if you do, you know, appreciate it. If you don't, then it's something you really need to stop and think about and think, how can I manage that? How can I manage my way around this relationship that's not ideal? And that's probably a topic in and of itself. We could discuss that. But, you know, being lucky to have a great relation with my advisor, and, you know, also just at a personal level, many PhD students, you know, you're young, relatively, you know, just out of school, new place, new culture, new things to explore, fewer responsibilities, which, you know, tend to come later in life. Of course, some folks, even as PhD students, have very significant family responsibilities, but it can be a great time, and I was lucky that I got to enjoy it. So, you know, I hope that's the case for you as well. And finally, I also want to echo what Sandra said about enjoy having one project. You have one project that you need to deal with. You have one person that you need to make happy. That will never happen again. If, as a PhD student, you feel like you don't have time, and you know there's a good seminar coming, and you know you're going to skip it because you don't have time, trust me, you don't know anything about not having time. Enjoy having one project that you need to worry about. Enjoy having one person that you need to keep happy, and you know, keep pushing forward.
Thank you so much. These are awesome answers. I feel like we could end the panel right now and we would all still have benefited a lot. I'm going to start going through some of the questions we had pre-submitted. The one we got by far the most is just how do I prepare for a job in robotics industry? And we'll get more specific about the different parts of that. But let's just start there with how should a student prepare themselves for a job in industry?
You want me to go first again?
Why not?
Please.
I actually believe there is not only one answer to this question. I believe there are many answers, and they're all correct. And let me just share a few, and I'm sure that there's a lot of space for Sandra and Matei to add to it, and then we can probably use the rest of the time to talk about that. But when you say robotics industry is very diverse. There's, let's say, old school industry, old school engineering. There's nothing bad with that. That's a very different atmosphere, very different profile, very different style of work, very different culture at work. Compared to, let me use another example, some Silicon Valley startup. There's a little kid, raised some seed funds, like got 2-3 million of seed money. Lots of risk. No one knows whether it's going to work out. Most likely, actually not. But lots of excitement, doing something entirely new that no one else has done before. And the style of work, the culture is vastly different if you just compare these two extremes. And then there are many things in between. Like Sandra, for example, and I'm sure you can talk about that, as like working at the research department in the industry. Again, very different profile and very different style of work, very different culture. And so the answer actually depends on what you mean by industry. And then let me talk about another dimension here, which is all the different domains. The robotics is a very broad field. Like at a super high level, obviously you have like mechanical engineering, you have electrical engineering, you have computer science, maybe data science, and it's like the intersection of all of these disciplines. But if you then look at the application domains, maybe you're interested in like medical robotics, and then you might need a relationship to the domain of medicine. If you think of mining robots, if you think of industrial robotics or service robots, there's a long list. If you look at the handbook of robotics, just the chapter on application fields it's a big chunk. I think it's like 400 pages, just that. And now you can see just by these two dimensions, there are many answers. Like if you just think of like all the subdomains and then the different companies, if you think of a matrix, and let's say this matrix has something like, I don't know, at least, let's say 20 by 50. So that means we have at least 1,000 answers for your question here. And which one is the best way for you? Only you can decide. And I'm not saying that one way is better than the other. It also depends on what you want. So the way I would approach it is asking yourself, what is it that you want to do? And where do you see yourself, let's say, in the next 3 years? What is it that makes you happy? What is meaningful to you? And because what's meaningful to me is not necessarily meaningful to you, and vice versa. And then imagine this matrix that I tried to describe, and pick a field in this, and see whether you can find an entry there. And we had talked about conferences earlier, having a network that for example, you can establish at RAS conferences is going to be super helpful, like amazingly helpful. Getting into any company through someone you know is significantly easier than just submitting your application. So for example, at Google, Sandra knows this as well, the acceptance rate, overall acceptance rate, actually Matei knows this as well. All three of us have been working for that company. It's less than 1%. So it's if you just submit your resume, that it's much more challenging. However, if you know someone, that is the way to go. I'll pause here. I can speak much longer, but just to give a framework.
So I can echo to that. I think first step in preparing yourself for a job in industry is to understand what is exactly that you're interested in doing and why. What is the driving factor and what is the environment that you thrive in that kind of motivates you, that wants you to get up in the morning and do something exciting, industry or not, right? And then within industry, roughly speaking, there is the researchy part and we can kind of put that aside, or there is a startup or established, as Torsten had mentioned. So they're all different purposes. Are you interested in spending the majority of your waking hours thinking and breathing about delivering something to the customer and making customer happy? Are you interested in kind of putting that energy and effort into inventing new methods, and that's kind of what gets you excited and motivated? And maybe that sees some, there are very different things to who is your community that you enjoy working and so on. So that's there. In the research, and I get that asked a lot, so I'll say it here. There is industrial research that doesn't publish and industrial labs that do publish. And it doesn't mean that one does better job because there is more, but by nature of things, if you are publishing, that's the open work and it gets seen and it gets people write about it and there's lots of talk. It doesn't mean it's better than the industrial research that's not publishing, that we don't hear about that and so on. And in fact, I'm going to argue that you can go and learn a lot from being in the industrial lab that does research and does not publish, where basically your job is what PhD gives you. If you're doing PhDs, you're certified that you're able to take a snarly, unsolved problem and figure it out. That's really what it does, and you've proven that on one data point. From there, you can go and solve another problem, or even kind of different discipline, or you can kind of continue that line of work that you started with your original thing. So there is, in the industrial research that does not publish, there is lots of real world problems that are at orders of magnitudes more complicated than anything that's being published that can fit with 6 to 8 pages plus references in 5 minute spotlight presentation, right? So it kind of gives you a different perspective. In terms of how to go about, so if you kind of know what motivates you, what are the options, question is how then to get to the options that interest you, comes back down to networking. And establishing, being known, right? As Torsten mentioned, like having connections and knowing people helps. And I'm going to also add that these opportunities, knowing people outside in a separate context than research, also helps a lot. So exactly this panel and so on, these are good opportunities to broaden your network to maybe people that you normally wouldn't encounter and whatnot. From kind of, if you're thinking about your connections related to the work that you're doing, I found it useful to kind of think of, okay, you're developing certain methods. There are people that are developing similar methods. These would be your method peers, right? These would be people in the context of the paper that are your baselines and whatnot. But there are also two other peer groups. One are the people whose methods you're using, and these are good friends to have because you're basically making their work meaningful or significant in a different way. So it's kind of good to know. There are also a group of peers that might be using your tools and your methods in their work as part of the larger solution. And these are very good network and peers to have because you provide something useful for them and so on. So it's helpful to kind of think of that perspective. And I can give a whole talk, and when you're developing a talk or kind of giving talk how to address all three groups of people there. But anyway, it's helpful to think from your net perspective of your network where people kind of fall in.
I think that's terrific advice in terms of which people to, how to connect with people. I hadn't thought of it in the sense, but it's a good way to think of it. What I would add is that also in terms of networking, when you have finished your PhD and are looking for a job, that's when in an ideal world is where your advisor jumps in and helps you make connections. To me, that is part of the advisor's role. For years and years, you've had, you've worked in that lab and you've helped advance the lab's research agenda. Now is the time for the advisor to step up, put themselves out there, email everybody they know and they think would be a good match and say, hey, I've got this terrific student graduating. Do you want to talk to them? And, don't be afraid to ask. It is your advisor's job to do it. If they don't, of course, not everybody is lucky like I was, to have an advisor who takes their responsibility towards students very seriously. But don't be afraid to ask and leverage your advisor's network. That's one thing I wanted to mention. The couple of other things, right? Both Torsten and Sandra talked about being broad, and it helps so much. It's relatively unlikely that you'll find a job in industry based, on the strength of exactly what your PhD thesis was on. It's just rare. Of course, it'll be in somewhat related field, but it won't be exactly that. So it does help to be broad, to not just be stuck just looking in great depth at your thesis topic. And what I have found is that, a PhD student's sort of interest in things around tends to vary. It's kind of an hourglass shape. At the beginning of the PhD, students are excited and they want to do this and that and drones and humanoids and manipulators and everything under the sun. And yes, I'm doing research in robotics and the moon and the stars. Then in the middle of the PhD, they're like, oh my God, I will never graduate. My project will never work. I will never graduate. I need to remove any distraction and just focus 110% on my PhD thesis. And that's when they just completely lose anything that's, to the left, to the right. They just get completely focused. Then when the end of the PhD is in sight, so when their senior PhD student's almost done, now they say, oh, okay, what am I gonna do next? I should get more interested in things. They start looking around again. They feel more secure because they feel that they have enough to graduate. So now they're secure. They spend more time going to this interesting seminar or that interesting seminar. They have more knowledge, which allows them to understand more. So again, at the end of the PhD, the focus again starts to get broad. So I would advise to try to avoid that middle of the PhD narrowing. Try to keep some breadth throughout. Stay interested. Go to talks. Engage. Help. Have a side. Help your lab mate with something for a little bit. Chime in. Go to talks. Read some papers that are maybe a little bit outside of your area of interest. And then when you're going to have that interview in industry, you'll find that many of the things that you considered secondary throughout your PhD end up mattering a lot when you're applying for that job in industry. And then, Torsten was saying how robotics is so broad that it's very hard to make concrete recommendations. And that's very, very true. But I think the one thing that is maybe generally applicable is in research, what tends to matter is the end result. Your final performance. Are you getting, 95% success rate? What's that final number? And that's what you're incentivized to care about. How you get there, the tools that you build to get there, if they fall apart the day after the paper has been submitted, so be it. You don't have much of an incentive to care too much about the tools. If you know that you want to go to industry after you graduate, take pride in the tools that you build. If you're on the software side of things, take pride in your code. Make your code way better than it needs to be just to get things to work. Learn the latest and greatest in software engineering. Adopt a style guide, for example. Nobody cares if your results are with code that obeys a style guide or not. The reviewers certainly don't care. Adopt a style guide, adopt whatever, Google style guide, and then follow it every day and take pride in the thing that you're building. If you're doing design and hardware, do design reviews, get your lab mates and do a formal design review. Have excellent documentation and BOM list and things like that. And just do things above and beyond what you need. Just take pride in the process, and then you'll be rewarded when it's that time to you're applying to be in a professional production environment, and all of those things will come in hand, will be useful a lot more than at the time of the PhD itself. Oh, and then one more thing, by all means, try your best to do an internship. At least one internship, one, maybe two if you can. Hopefully, again, so much comes down to the advisor relationship. And in a way, advisors are not incentivized to send you out during the summers. It helps the advisor too if you do an internship, because you broaden their network as well. But other than, in the summer, there are no classes, no distractions. So in a way, the advisor might say, no, be in the lab, crank out the next paper. ICRA has a deadline in September, so I want that ICRA paper. But the internships are so critical for your industry career, both to know if you want to work at that company or not, to have an offer at that company if you do well at the internship, to have on your CV the internship, to just learn how to be in a production environment. It's so, so important. So negotiate with your advisor to have that one internship, two internships. A very good friend of mine, and looking at the pride in the code. We were both PhD students. He, couldn't care less about the quality of the code, just the result. And then did an internship at Google, and then came back a changed person. Everything was like templates on top of templates on top of other templates. We had this running joke that his goal was to write the function that would do everything, would be so templated that you could have that one function do everything. And he came back from Google just a superstar software engineer, whereas before he didn't care about it, right? So that internship will teach you how to be in a professional production environment. So do your best to take advantage of that.
Awesome. So many great answers. Well, that leads us into where do you look for internships as a PhD? Maybe it's tied back to networking. Maybe there's certain places you look for postings. Maybe it's different now with everything being virtual. Where should PhDs look for internships?
I can start just for a change of pace. To give Torsten a break. So Traditional networking, good old networking. Find the companies that you're interested in, want to experiment, and find specific people that you might be interested in working. Now, when it gets to finding the specific people you're interested in working, beyond the conferences, there is increasing trend on social media, Twitter, especially for machine learning. I think kind of robotics is kind of picking up on Twitter as well. If you want to blog, that's also a good option. Maybe, yes, there is a paper, and yes, you open the source code, write a blog post, right? So summarizing these points and so on. Find somebody's work that you're interested in, so on. Reach out to them, say, hey, I really enjoy this work. How about changing it this way or that way, and so on. So these are some kind of options to start these conversations around it. And then things happen, right? The advisor, relying on the advisor, because part of you have the luxury of having the time to think about the problems, and advisor job is to kind of go and network and find where the internships are and so on. So yeah, that's kind of.
Yeah, I think in general, echoing what Sandra was saying, build a portfolio, right? So this is not, I'm not answering directly the question, by the way, Blake, because I think I don't have anything to add in terms of where to look for the internship, but in the how you look for the internship, you must have a portfolio, and your portfolio should be well done. You should put a little bit of thought and work into it. And usually, it's a website, maybe it's your GitHub IO or maybe something else. And in your portfolio, you have the key projects that you've worked on, what you did, the key findings, nice images and videos of the results. Put a little bit of work on it and in that, put some thought into that, so that when you do reach out to people, you have a very quick way to present a good professional version of yourself. If you're mostly on a software role, then of course your GitHub account is part of your portfolio, but you want more than that, right? Just like Sandra was saying, have a blog post about your latest paper. In your website, in your portfolio, have a couple of paragraphs describing it and stuff like that. So build that presence before you start contacting people and saying, hey, I'm looking for an internship.
I don't think I have much to add to that. So really using networks that either you already have, that your advisor has, strong +1 to what Matei just said, build a presence in various ways. And I think the probably most respected one is actually a university website. Like if your university offers you to have like a personal website, that would probably be my recommendation. Also, as someone who has been looking at many of those resumes, I think this is definitely something that I look at. But that's speaking very much for myself here. I'm sure that there are many other people looking at it in a different way. And if you look for opportunities, I'm sure many, if not all of you, are signed up for Robotics Worldwide. Companies that offer jobs very often also offer internships. So don't be shy to reach out to people who are offering jobs. They will very likely at least also offer internships. And also last thing to say here, even for interns, the robotics field is growing so fast. There's a huge demand for talent, even for interns, so that you should also be picky. If you feel you have several opportunities, make sure you pick the right one for you. That's really the one that is most meaningful to you.
Yeah, I just want to add on a portfolio building, and I'm going to quote Dave Patterson. If you don't know Dave Patterson, he was professor at Berkeley, Turing Award winner. His advice was that early on in career, you should spend about 40% of your time on building portfolio and kind of marketing yourself and developing the network and so on. And that's time well spent. So that's a lot of time. So related to that, I tend to hear and often hear that, well, if I just do this one more method, my stuff is not good enough. If I just do this one more method, then I should go in and kind of focus on expanding. Don't. Because there's always one more method, and it's always that curve, the accuracy curve, or whatever the curve is that you're kind of chasing is elusive one, and so on. So build from what you have, own what you have, and then grow along with the methods you develop.
Thank you so much, everyone. Let me ask you to put on a different hat for a second. So imagine now you're hiring, you're looking for new talent into your organization. What skills are you looking for? What's really in high demand right now?
Let me start actually with just setting the stage and setting up a framework here. For that question, again, there's no one-fits-all answer, because it will think of my previous answer, like all of the different domains, application domains, and then also the different types of companies. So there, actually, and even within those, let's say you identified one field in this matrix that I described earlier. Even within one single field, there may be people needed that are very broad, have like a very broad expertise, and there may be people needed that have a very deep, very narrow expertise in one specific field. And so again, no one fits all answer. I can share, this is a rather personal, the way I look at things. And I'm not claiming that it's right or wrong. It's just the way I happen to work. I care deeply about technical expertise that is really solid, like starting with math. I typically have interview questions with math and coding, and making sure that you understand the foundations. And then it's sometimes shocking to see that even people coming from the greatest schools, greatest advisors, have a problem with linear algebra, or are not able to implement binary search. Like really, I'm literally talking foundations, not even something advanced, not even anything data driven, and explain to me how, I don't know, backpropagation works or any of that. And then also in my very specific case, I'm really looking at people who are great coders and great team players. So there are two aspects to it. I also want to make sure that that the person fits to the team culture-wise. And one mental model I like to use is that I try to imagine, am I ready to go camping with that person? Is this going to be a fun trip, or will I be happy to be home afterwards? I'm not saying this is right or wrong, but if you feel that there's a good resonance in the room and a warm atmosphere, that typically helps and brings the team along a lot more, compared to you bring on one person who is maybe the super crack, but he just destroys the atmosphere that you already set up.
I can go next. To echo Torsten, I'm going to speak for my team, and I am in the industrial research that's kind of mostly aiming at the academic publishing. So we're do publishing and so on. So maybe we're close to university and so on. So one thing that we need to do is make sure that the research interests are aligned, and that there is the foundation, and that's easy to check through publications, right, and so on. Now, second, equally important is the fit to the team. And the things that I'm looking specifically is willingness to learn new things, willingness to listen to feedback, and the team player, sharing the responsibility, the delegating, working in partnership, and then the engineering part and the coding part. That if we could just have papers without anything, no code and so on, it's not. But the reason for the soft skills in terms of learning for feedback and willingness to hear the feedback and work on it and learn new things is because then if we have that foundation, you're smart. We can learn other stuff, right? You can add specific methods and so on, but if we can't share the feedback and kind of areas for improvement and things get defensive and whatnot, then there is no communication. The teamwork, the importance of the teamwork is one thing I tend to kind of tell the interns when they join is that industry is very different from the academia, even though we're publishing, and in a sense that your advisor's role is to graduate you. And that means that you need to learn every step of the research process to do on your own. That means writing papers, developing methods, right, the networking and so on. When you graduated, you're certified that you can do that. Industry has a different objective. The objective is to push the state of the art of the science and whatnot, and it's a bunch of us working in this space, and you don't need to be one person show, right? If you enjoy writing papers, and I hate doing that part, so by all means, go ahead and do it, right? And that means that we can pair up to do different things in order to kind of achieve the common goal. And this is very different mindset than the one the academia has. It's a worth having conversation on that aspect. And so yeah.
So yeah, not all that much for me to add. It's crazy how many people don't know linear algebra. It's when Torsten was saying fundamentals. Oh, I was thinking I need to chime in on that and talk about linear algebra, and then Torsten talked about linear algebra because that's what I ask as well. Yes, and you know what skills are the most important these days? I mean, you know, I think at some point we have to address the elephant in the room and do say that this is a peculiar, crazy time where everybody has gone crazy about machine learning, and certainly so have we. And in my lab, and yes, there are more jobs available for roboticists in sort of the coding and machine learning side of things than for other areas. And I think that's a shame. I think that's holding the field back. But I think I would be doing everybody a disservice here if we didn't acknowledge that, yes, there are more jobs on the learning and the software and the AI side of things. Is it a hype that will subside in a couple of years by the time you graduate? Is it going to be sustainable? We don't know. Of course, that doesn't mean there are only jobs in those fields. You can still be an incredibly valued roboticist if you do mechatronics and design, or if you're an expert in sort of traditional control systems. Absolutely, there will be opportunities there as well. There just seems to be more pull on the learning side of things. And then whatever the skill is, the advice that I would give is, another thing that's a bit of a shame is that interviews often select for extroverts rather than introverts, which you kind of should, people, you want to see what the person knows, but you have 1 hour, 2 hours at most to know that person. And we are human beings, the connection will matter. So even if you're kind of more of an introvert in nature, which is perfectly fine, you can do amazing work, try for the interview to summon, excitement and put yourself out there and be forthcoming with details. And if you're excited, let your excitement about the work and your excitement about the company that you're interviewing for, let those show. It's very important. And even if that doesn't come naturally to you, try to find a way to do it. I'm looking for problem solvers. I want to see that you found the problem, you understood it deeply, and then you figured out a way around it. You didn't give up. You didn't wait for somebody else to solve it for you. You didn't take the first hack without understanding what was going on. I want to see that you're a problem solver and that you love problems, you embrace them, and then you find solutions. And that's kind of across a wide range of skills. And do your best to let your excitement show.
So good. So a lot of soft skills are coming out. Looking the other way, as a student looking at joining a new team, how should a student, or what should a student look for a good team, a good culture? What's a red flag maybe? Matei, would you like to start this one?
Yeah, I'm just thinking about, you know, red flags that I've had in my career. And I guess to me, a red flag is, it's hard to say. For example, one red flag that I have found is people being very dismissive about fields that they obviously don't know much about. You know, you're interviewing and then you're talking to somebody who is, you know, talking down kind of a range of methods or a specific approach, which makes it, but making it quite clear that they don't actually understand what's going on there. That to me is a red flag in terms of culture. You know, people who don't have buy-in into the big picture. You know, you're interviewing, you're going to talk to 8-9 people in a team. You're going to talk to the team leader, the manager, whatever. And the manager is going to, you know, paint this big picture. Haha, we're going to, you know, boil the ocean. But you're also going to interview with sort of, you know, people who are just team members, not necessarily in the leadership. Do those people also have buy-in into the same big picture? Are they also excited? Or are they just, I don't know, I'm doing my little thing, whatever the other people do, I don't care, you know, let's talk about narrow technical stuff. You know, if there isn't excitement and buy-in from everybody in the team, then chances are something's wrong with the culture. And then ultimately, you know, there's just so much, it's, you know, from both sides, from the interviewer and the applicant side, I've just made my peace with the fact that it's impossible to know a person and it's impossible to know a workplace based on the interview process. You do your best. It's a risk. You only really know each other after you've worked together for a couple of months. Do your best, but make your peace with the fact that, yes, there are things that you just cannot tell in an 8-hour interview on both sides.
Some red flags to kind of echo what Matei was mentioning are around disconnect between leadership and ICs or even different groups. Perhaps some things around the culture. Is this joint teamwork culture, or is it everybody goes on their own, or teams going on their own? And are we playing collaborative or competitive games here? The just kind of knowing what you're entering. What is the process for starting projects, for getting new ideas heard? What is the process for shutting down the projects? So there are some questions that you can ask at different levels of the company. So it's good to kind of do some leadership interviews with some leads that normally you would, and the IC and the individual contributors or peers, and kind of see whether you get similar or different questions. Is this the environment where there is one shining star person and others are kind of helping that person along, or are there, how's the talent being growth? What is the career path for you in the company or the others? Are people get promoted? Are people leaving their current jobs because they get promoted and they get better assignments and whatnot, or they're leaving because they left the company, or they're kind of sitting there with kind of career flattening and so on. So these are some questions to ask. leadership. Something it was not clear to me earlier in career is that the moment when I learned what my senior manager is doing, it was a bad news. that a good senior leadership will make things seamlessly. Things will just kind of fall in your lap when you need them. You'll have the lab space, you'll have the funding, you'll have the computer, well, whatever it is that you need, things will just kind of show up magically when you need them. That's a sign of your senior management doing their job properly. The moment that they don't, you will notice. So that's kind of a little insight to know. Third question that kind of you should be asking yourself more than a company, and it's kind of question of the fit, whether you are in the environment where you are the star, in a sense, where you kind of have the knowledge and so on, the expert, and that can feel good, but it's a lonely experience. Or are you in the environment where your peers are challenging, and they're experts as well, which then the opposite to that is that you always feel like the imposter syndrome loud and clear, but then you might be learning more from the peers and so on. So you're kind of one of the pack and so on. And that's very personal. It's a very personal decision and something to think about. It may even vary between kind of different jobs or assignments, right, along the career. Sometimes it's good to kind of be in one setting versus the other. And ask open-ended questions because they reveal a lot.
Great answers of Matei and Sandra. I don't have too much to add, to be honest. I maybe just two minor things, but I think both Sandra and Matei covered the majority of my thoughts as well already. But maybe the two additional pieces I'd like to add. Depending on the company, like you can also find information in the internet about the culture in a certain company. And it may be worth to do your own background check. Maybe if you have a network, if you know someone who works at that company, just hear them out, feel them out. Also do your own homework. And then the second piece of advice, and I'm actually saying this mainly because robotics is such a hot domain and growing so fast, and there is a strong deficit in terms of talent. Don't undervalue, don't underappreciate, undersell yourself. And it's not only that you are applying at the company for an internship, they are also applying at you. And then so the interview process, and I'm tempted to say with all interviewers, it should ideally be a conversation at eyes level. And if you get the sense that you are being looked down at, or you are disrespectfully treated for whatever reason, I mean, you will feel that. I don't think I have to share too many details here. If you don't feel comfortable during the interview process, that can also be a red flag. Yeah, let me pause here. I think these are the only two additions I'd make.
That was so wonderfully said, that the interview should be a conversation at eye level. I've never formulated it like this, but it makes so much sense, right? If you're being looked down upon, bad. But the flip side is also true. I have found from experience that the applicant who comes in with the attitude, oh, I'm so hot, you convinced me why I want to work for your company, right? If the interviewer asks, why are you interested in our company? I don't know. You tell me. I'm the big shot expert here. You tell me why I should be interested in your company. That person doesn't get hired. Okay, so it should be exactly like Torsten said, at eye level on both ends. Also, very quickly, what Sandra was talking about, flat hierarchies. So true. Be very careful with that. It's a sword that cuts on both sides. Everybody says, oh, we have a flat organization, and you're tempted to say, oh, that's good because it means I have access to the hotshot director of such and such. Great, but flat organizations have very few opportunities for promotion. There's nowhere to go in a very, very flat organization. There's nowhere to go up. So be careful because it cuts both ways. So I think, Sandra's suggestion about ask what are opportunities for growth, it's a great one. How projects get ended. How could I forget that in one of my own interviews 10 years ago, more than that, I was asking the interviewer about, tell me about a cool project you've worked on. And the person got so excited. Oh, there was this project and I did this and that. And then I asked, well, it sounds amazing. So what happened? Yeah, well, they killed it a year in. Okay, huge red flag, right? If that can happen just like that. And then just one last thing I want to mention that I forgot to say when we were talking about skills and what skills to build. Whatever your skills are, make sure you know your own CV. For me as an interviewer, if somebody comes in and one of their projects is that they did something, and I say, okay, well, tell me about that. Oh yeah, that was 3 years ago. Nah, I don't really remember anything. It's just, no, that to me is a huge red flag. So whatever the skills are, make sure you know your own CV and you can go into nice, reasonable detail about anything that you've put in there.
Awesome. Thank you all so much. It's getting better and better. So we talked about AI for a second, and it's my understanding there was kind of a bubble around the 80s where all this hype, investment, and then maybe some of those technologies didn't deliver on what people expected, and into another bubble kind of like that now, or in the middle of it. But where do you all see the industry 5 years from now, 10 years from now? Certainly this things students are learning in school, sometimes it's obsolete in the workplace within a few years, but so we might have to get a little technical, but what do you see, the big changes in the next 5 to 10 years?
Want me to start again?
Or I can, doesn't matter. Yeah.
You go ahead, Sandra, if you like to.
Sure. Let's kind of do the open-ended, and then the bubbles. Sure, maybe there is a bubble. However, I think even with 80s or 90s and whatnot, we learned some lessons. And maybe one way to think about bubbles is that we reprioritized. So are we in the AI bubble now? Maybe, I don't know. But I think we're learning a lot in the process. And it might be that in 5 years or so on, we refocus and kind of put more emphasis. Okay, learning or software kind of came to this point now, maybe it's time to kind of look into different hardware, and then we'll kind of come back again and do it together. So that's an alternative way of looking into bubbles, is kind of focused prioritizations around the field. The second kind of comment of where the field is going to be, so let's see how we got where we are now, is that what we traditionally ask from robotics is to be in these fixed settings, industrial settings, where the environment is prescribed, and then maybe we have humans or whoever engineer the trajectories that the robots should do, and they do repetitive tasks over and over and over again, right? And that's where kind of control theory and so on, the safety and the guarantees in these aspects were super important. We're asking nowadays robots to do more complicated things, right? We're asking them not to perform in a single environment during their lifetime or most of their lifetime. We're expecting them to behave and do some intelligent things in unstructured environments. How many environments? Are they fixed? Are they not fixed, right? So what type of tasks? Do we expect them to do same tasks, different tasks, and so on? So I think kind of rethinking robotics, well, what's going to happen? Like, I think right now we have these implicit expectations of the robotics that are seeping in through the academic research. Oh, let's do this application, let's do other application on one end, and maybe autonomous driving on the other side. That is, autonomous driving in anything is kind of emphasizing this large scale, data driven, unstructured environment direction in a completely other end. So I think over the next 5 years that robotics should basically rethink why we're doing this, really what are different application spaces that are important, what we're expecting of the robotics in a little bit more formalized manner, and then from there, what are the methods, right, and the tools and the infrastructure and how we're evaluating robotics over in these kind of focused areas. Yeah, that's.
I can go next.
Yeah.
Let me make a distinction between bubble and hype. Are we seeing a hype? For sure. I think we all agree on that. Is it a bubble? I am actually not sure. And the reason is there's actually progress being made in the space of machine learning. Actually, just to make sure we use the correct language here, with media very often, and even some researchers like to talk about artificial intelligence. My perspective is that the domain that is making progress is machine learning, and this is what's starting to make the difference. It's a subdomain of artificial intelligence, but it is machine learning. And now, from a robotics perspective, I'm actually fairly deeply convinced that it's important to make a distinction between physics and non-physics. So, and sometimes I like to say physical AI and non-physical AI. So what do I mean by that? You can use machine learning, for example, for perception, visual perception, or even acoustic perception. And I'm convinced that this is a domain that will add tremendous value to robotics, and it's happening already. And not only in robotics, actually, in like just think of what is happening in the computer vision community, or if you use Google Photos or any other photo service, like the annotations that are being made automatically for you, it is tremendous. And having robots being able to have a semantic understanding of what's happening in their surroundings is huge. This is like even 5 years ago, this was not really, or definitely 7-8 years ago. No one was dreaming, no one was thinking that that would come so soon, and now we almost have it. But these are things where we can do a lot of progress with vast amounts of data that are often synthetically generated. The challenge, and I actually believe, and let me be a little bit pessimistic here. And I would love to hear actually Matei's perspective on this, given your background in grasping. I believe everything where physics is involved, where the robot has to make contact with the environment. This will remain a huge challenge because you can't easily generate data artificially. There's no good physics simulator out there that would give us high quality data. So data collection in the real world is very expensive. Data is very rare. We do not have a lot of data. That also means that all of the machine learning algorithms do not work as well, at least not at scale. And as we need to find different ways to have algorithms that work with very little amounts of data, very small amounts of data, but the results are just not as amazing. Or we need to kind of find a way to bridge between data coming from the simulator and data coming from the real world. So there are other techniques we need to be looking at. But this will remain an open problem. I'm not foreseeing any huge breakthroughs in that space, being the pessimist in the room and admitting that. But still, even just on the perception side, this will create so much value that even if it's a hype, value is being created, and so I'm not too concerned about things. And the last thing I would like to add, and then I close my part here. We're seeing a lot of people, especially in academia, trying to do end-to-end learning, and we have seen that since a while. And I think I can totally see why academically that is interesting. No mammal on this planet works this way. If you think of how motor control of human beings, like how we do motor control, it's not that we just have one big brain that does everything. There are multiple abstraction layers, even in the human body. And we need to find these abstraction layers in robotics as well. And I think that is actually the key. And then we should use machine learning as a tool and not as a solution to solve this. And one distinction I see is that in academia, people are really keen on end-to-end learning. And I think that actually is a bubble, I would even say, maybe academically interesting, but from a practical perspective, it's close to zero relevance. And finding the right abstraction layers to then use machine learning in a smart way to solve the problem in a more immediate fashion.
There's a lot of interesting things in there. You know, it's really, we're also starting to veer and become a little bit more technical in the conversation, which is probably a good thing. You know, I don't think there is a bubble because, like Sandra and Torsten said, there is genuine value there. And it's not just the machine learning. One thing that's often underappreciated is how long it takes for things to translate from academia to industry. And a very typical time scale is about 20 years. And you see it again and again and again. And what we have right now is a beautiful kind of full pipeline in robotics of things that were started 20 years ago and now are incredibly mature and being very successful in industry. Look, for example, at, you know, just SLAM, probabilistic robotics and SLAM. When was ProbRob published? I think it was 20 years ago, maybe even 25 years ago, right? And then, you know, the robots, research robots navigating in museums. Then in 2010, you know, G mapping, AMCL, kind of starting the transition, Willow Garage implementing the RAS nav stack. And now 2020, you have incredibly successful robotics companies whose technology is fundamentally SLAM in, you know, warehouses or hospitals or things like that, being incredibly successful. And there you go, you know, it's 20 years. So we have this pipeline of things that were started 20 years ago, things that were started 10 years ago, like, you know, the deep learning revolution that came to robotics maybe started about 10 years ago or more recent. Things that are happening right now, that are hot right now, you know, end-to-end motor learning, reinforcement learning, like Torsten is saying. So I think there's undeniable value in all of those, right? I mean, it's enough. You see a Waymo car driving around and you know there's value there. And yes, we don't have the last mile. We don't have autonomous cars everywhere. It's impossible to see a demonstration of a Waymo car and not think there's something of incredible value there. The market stuff will come. Or to see the Boston Dynamics videos and to not think, wow, there's something there. There's something of value there. And maybe, sure, nobody has yet figured out how to truly monetize those incredible motor skills that Boston Dynamics robots have, but it's coming. It cannot be a bubble, right? A bubble, when it bursts, there's nothing left. Now there's incredible value in the middle. So this is, I'm also convinced this is not a value. This is not a bubble. Yeah. Then, you know, in terms of complicated, hard problems, yeah, navigation is way ahead of manipulation and things that involve sort of more transient, intermittent contact. It's interesting, you know, Torsten, I completely agree. And I think it's okay to get a little more technical on things. I don't know, just I completely agree that there's no simulator that is, you know, accurate enough for transient contact problems. But to me, the idea of domain randomization and sim to real transfer via domain randomization, that to me is huge. It's a massive advance in the field. That realization that you don't need, thank you, you don't need a perfect simulator. And when I say we, I take credit for it. We as a community, not that I necessarily did anything or that. We as a community figured out how to use huge amounts of computation and bad simulators, for lack of a better word, and get things into the real world. And, you know, people will say, well, okay, where are the applications? Why don't I have a robot emptying my dishwasher? 20 years, people, 20 years. These are things that are happening now in research, you know, in the last 3 years, 4 years. It always takes a decade, maybe two, and it's coming soon, meaning 2 decades to a dishwasher near you. There is value there. I strongly, strongly believe there is value there.
If I may chime in on the simulators, I think where kind of field is going is that the question we ought to ask is, what is the cheapest simulator that we can build that can support the sim to real transfer? And that building can be also learning and updating simulator, basically having, right now we're having the open loop. So there is a simulator, then we do a model, and then we put it in a real world, and it's like, okay, we hope for the best, right? But how about if we close the loop and provide that feedback and update the simulator in some way? Simulation had made huge difference for other domains. This is kind of a bit a radical example, but nuclear testing is all done in simulation, right? So if we, as a civilization, figure out to do that type of stuff, with enough effort, we can figure out the contact dynamics as well. I'm a big fan of simulation.
Thank you. Each, we might need to set up another panel just to go deeper on that subtopic. We've talked a little bit about entrepreneurship, and I'd like to speak about that next. So if you're a student nearing graduation, maybe you're thinking about taking your own idea, starting a company, or joining a small startup. I know a lot of companies now, the goal is just to get big enough to be bought by a bigger company, right? Like Google, NVIDIA, something like that. So what advice do you have for students who have that like entrepreneurship bug? Yeah.
Let me jump on this one. Let me go first on this one. So the one lesson that got sort of drilled into my brain in my 5 years in Silicon Valley is that if you're building a startup, you need to, the single most important thing is whose pain point your technology addresses, who's going to pay money for it, and why. And it doesn't matter how cool the technology is. It doesn't matter that it seems like, you know, a few years from now it's going to change the world or whatnot. What matters is today there's somebody out there who couldn't care less about what the technology is, but they have a pain point and they're willing to pay money for that pain point to go away. And does your technology do that for them, and who that person is? So if you can get into that mindset, that's the single most important thing about, you know, starting a company. You have for a second to forget about all the technical stuff and just go and find that person. You know, I think about Kiva systems, right? The example that I give is, you know, we all know about Kiva and the huge success story being bought by Amazon. They had this wonderful video where they explained what their technology was. And in that video was a picker in a warehouse that had an empty tote in front of them. And they would just turn and the object they needed magically appeared in their hand. So then they put it in the tote. Then they turned again, and the next object that they needed magically appeared in their hand. And then they put it in the tote. And that was genius, because notice that the actual Kiva technology wasn't even in that video, right? Because the Kiva technology is the technology by which the object magically appears in the picker's hand, so they can put it in the tote. So, you know, the customer doesn't care what your technology is. It could be magic, it could be whatever. If it addresses their need, then they'll be willing to pay money for that. So can you forget about all the cool technical stuff and know who that person is? Because you'll need that to raise any kind of money. You'll need that to get started. You'll need that to get bought, you know, a few years down the line. And then the other thing that I would draw attention to is, you know, a more recent success story. You know, Fetch Systems got acquired a few weeks ago. I'm sure many people saw in the press. And I was reading an interview with, you know, Fetch's terrific founder and CEO, Melanie Wise. And she was saying that we just started off, we wanted to build something that worked. We didn't want to get acquired. We didn't want to IPO. We didn't want to whatever. We wanted to build something that was useful and something that worked. And I truly believe that that's how Melanie and, you know, her team in the early stages did. This is how they actually functioned. That's how they set the culture of the company. So don't think about being acquired by Amazon or Nvidia or Google. Think about, is this thing, you want to build something that's useful for somebody and something that actually works. And then, you know, the rest is gonna take care of itself. And thankfully, if those two criteria are met these days, robotics is so hot, as Torsten was saying, that chances are very good you'll be able to raise the capital you need to get off the ground.
I can go second. This was a great answer. I'm just gonna add a couple of thoughts. Everybody should do a startup or be in a startup at some point in their lives, because and to some extent there is perhaps more similarity between academia and a startup, in the sense that there is lots of unknowns and it's lots of unstructured, and to Matei's point, whose pain point you're addressing and why. Having that clear, that's very important for kind of grant proposals, right, and papers and whatnot, and figuring out the resources to do it, and not having other teams and other kind of partnerships and whatnot solving problems for you. These are the similarities between the academia and startup. So being in a startup setting where you're really, like, your livelihood depends on the success or not, and whether you can solve that problem, and you never know what's the next problem that's going to be ahead of you. Even if you're not the owner or the CTO or CEO of the startup, you still need, even as a software engineer, for example, you're the admin as well. You're the tech support, right? You're everything. So you get very quickly learn to wear many different hats, and to not know what is the next hat that's coming down your way, and basically think on your toes and so on. And that's very, very different than industry work in well-established company, in which case you have teams that kind of solve things, and there's difference in speed as well, how quickly you can pivot, how quickly you can change the direction, and so on. And there are pros and cons to both. But and then just the last point, in the startup, you can do your own startup, in which case you're kind of having a whole bunch of things. Also, there's value in being in a startup and learning by observing how things are being done. And these lessons learned will kind of carry on through the career.
Great answers. I've done this actually. I talked to my wife the other day, and we found out that I founded 8 companies in my life, which is a little shocking to myself. They were not all deep tech. 2 of them were deep tech, and I would like to strongly second. I think Matei's framework resonated a lot. I can add much more to that, and also much more to what Sandra said. But I would like to offer another dimension to this discussion, and that's about lifetime. So when you get out of college, of course, I cannot speak for everyone, but if you think of your life, your career and let's say you get out of college in your mid-20s, and let's say you want to retire at the age of, I don't know, 60 or 65, whatever it may be for you. That means you have roughly 40 years of professional life in front of you. That's a lot of time. And I always like to think of lifetime as a currency. That's the only currency that's actually finite for all of us, no matter how much money you actually have or will make in your career. And I have mentioned the word meaningful a couple of times. I always like to optimize for doing something meaningful with my lifetime, and then everything else will follow. Now, being a startup also is a risk, because you don't know whether it's going to be more funding, or maybe it's going to be shut down, or it's not going to fly, or there can be many things that can happen to startups that makes it unsuccessful. And the truth is, it happens to many of them. But the experience and learnings, and I think both Matei and Sandra talked about it very well, will enrich you as a person. And if you imagine you would work in a startup just for a year or 2 or 3, and that even then, let's say you decide you don't like it, and if you like it, even better, maybe you want to stay and there's a huge upside, and you can retire at the age of 30. That may also happen if you're lucky. But just the learnings that you make and during that phase, because exactly like Matei and Sandra said, there's so many things you need to do. It's much broader, much more chaotic, much messier. That is something that no one can take away from you. And no matter what job you're going to be taking later on, that's a super valuable learning just for you yourself, for you as a person. And no one can take that away from you. So I would also not underestimate that, not looking at any finance aspects of all of this. I hope this wasn't too meta.
If you have luxury to do that.
I mean, you will make some money, right? You won't starve, even in a startup.
It's awesome. So some great experiences that y'all can share with us. I think we're about to our last question here. If you could time travel back to when you were a PhD student and have a conversation with yourself, what would you tell yourself? What do you wish you had known back then? It could be about anything, any topic.
My very honest answer is I'm not even sure whether I would do that. Because the learnings that you do that you go through as a PhD student are, as a PhD student, you have a lot of freedom. And that's also a unique phase of your life. And I think back of this 40-year example that I just gave, like time as a PhD student compared to the 40 years is a fairly small amount of time, a fairly small investment of lifetime, given the experiences that you're going through. And I think going through these experiences is actually what it is about. And then getting advice from your future self may be a fun thought, but I'm not actually sure whether that serves the purpose. If I had to do it for my very self, the mathematical problem that I was solving was at the end actually a fairly simple, very beautiful structure, but it took me years to discover that structure. And you can actually describe that structure on like 2 pages. And I would probably give myself those 2 pages early on so that I can finish my PhD in 3 or 5 years and not in 8 years. But I would still do it again in 8 years. It was worth the time.
Not directly answering. Is it funny how some, in retrospect, obvious reflections take a couple of years to get to? This is I guess this is several examples. Like, took me a couple of years to get to something, and then in retrospect, like, yeah, it's completely obvious. That's the case. But that's the beauty of it. What would I say? What would be the advice? I think one advice that would be for me, and this is more personal, is to go and trust my gut feeling. That the intuitions or technical intuitions, what problems to tackle, and so on. Follow and then commit to them. Because there is a big uncertainty, right? And you don't know whether your intuition is right, whether this is really the right problem to solve. And if you invest significant amount of time into something, whether that's kind of meaningful or not. So yeah, less doubt on the problem space and more time on the actual execution.
Yeah, I would maybe just, things that I wish I had realized maybe a little earlier. One of them is, I mean, and they're related, right? One is that I've never seen research breakthroughs, right? Like today it's not working, and then tomorrow you've had the breakthrough and now it's working. And that doesn't exist. the eureka moment, all of a sudden the illumination. No. Research is just, it doesn't work. It still doesn't work. It still doesn't work, but maybe it doesn't fail as miserably as before. Now it still doesn't work, but maybe if you look sideways and it kind of sort of works. And hey, it still doesn't work, but isn't it way better than it was 2 years ago? Let's publish a paper. That's research. It's 2 steps forward, 1 step back, 2 steps forward. And the PhD is just so long. So, don't chase that breakthrough eureka moment. Just accept the marathon nature of it. You just keep making, constant progress. You keep, you trust your intuition about where you're going, and it's slow progress, but eventually, you get there, or you get somewhere, and maybe it's not where you thought you'd get, and just make your peace with the fact that that's how research works. And, since it's not about sprinting to get the breakthrough, because the breakthrough as it is, as such, doesn't exist, it's about progress over time. Just be disciplined and have a good schedule. Take care of yourself. Be very professional in your schedule. You're not a student anymore to pull crazy all-nighters and then crash for a week and then work for a month nonstop. And then no, just treat yourself more like a professional and less like a student, and trust the process, trust your intuition, keep going. And eventually you'll get maybe not exactly what you think you're gonna get, but you'll get somewhere good.
Thank you all so much. I've certainly benefited a lot from these answers, and I believe we recorded this. I'll be listening to this again, but really appreciate you taking the time out of your schedules to be here with us. And was there anything else that any of you would like to say to our attendees?
Thank you so much for organizing and for attending.
Great pleasure to be here. Thank you so much.
Plus one, thank you to Kara and to Blake for making this happen, to Amy, Alexis for the support, and to everyone attending. Thanks for your time. This was fun. Happy to do it again if anyone likes. And yeah, and enjoy the rest of your days.
Thank you to everyone.
Thank you.
Thank you.